Today we want to discuss the difference between predation and parasitism. In a lot of ways they're the same thing. We're looking at an interaction between two organisms, one being a predator type and one being a prey type. And so in many cases we think about the difference being simply that with predation, it's one freestanding organism feeding on another. So things like the interaction here between our gray wolves and moose. So when we look at this interaction, you see the moose population increases, and following that, so if this is the peak of the moose, following that we see an increase in the wolf population, but following that we see a decrease in the moose population. As the wolves then go down, the moose go back up. So why do we see this complex interaction? Well, you have to think about, if the moose populations are high, the wolves will do well, and in the future, the following couple of years, their populations will go up. Well, if the wolf population goes up, they feed on more moose, the moose population goes down, and so on. So it's this cyclical kind of nature. We see this all kinds of species here, and a snowshoe hare and an Arctic lynx very much interacting, and you see this slight delay in the red, which is the lynx, following the snowshoe hare. So the bunnies do well, then the lynx does well, then the bunnies do well, then the lynx does well. Okay, so we see this constant back and forth from year to year to year. Now, when we look at parasitism, though, we talk about the idea that this predator is feeding on the prey, but it likely is not going to kill it. Because remember, a parasite is likely living inside of you or inside of its host, and if it kills the host, then it's out of luck, right? So really what we look at is this parasite, so say a roundworm in you, a parasitic wasp laying its eggs in a caterpillar, all of these sorts of things. But what we really look for to compare predation and parasitism is what effect is it having on the population. And really what we see is the population is essentially being controlled by these parasites and predators. And what I mean by that is it's getting rid of the weak. And now, to many of you, this may seem kind of sad, right? But we have to think about the fact that if a prey item is available for a predator, the predator is going to do better. And if the predator is taking down weak members of the population in a social structure, that's very important. Remember, the weak members of a population slow down that population in their migrations and so on. And so it really is sort of this evolutionary arms race or competition to make sure that this interaction between the predator and the prey item, whether it be straight predation or whether it's parasites, we see certainly this interaction that's very important for both populations. And we often see kind of a coevolution effect. And where we see that most is when organisms start to develop what we call mimicry. So this is a predatory frogfish, as I have here for you. And you see this little spine thing at the top. And essentially this little spine is shaped like a worm. Well, why would a fish have a worm-shaped thing on the top of his head? Well, yeah, he's hoping that the little fishy comes in here to eat, or to try to eat this worm, and when he does, when the little fishy bumps into this worm, this fishy comes up and goes grump and eats him, right? Interesting adaptations. We see these kinds of adaptations all over the place, often in something known as mimicry. So batesian mimicry is something known in many forms in the environment, but often associated with arthropods or bugs, right? So this is one species copying another to get some sort of protection for it. And what I mean by that is this. So these probably look very similar to you, right? Can you pick out the differences? Well, some of you may know that this is a yellow jacket or a bee, wasp type, right? This guy looks on the right looks a whole lot like him, but he's not. He's just a moth. So have you ever seen a moth like that? Kind of cool, right? So the yellow jacket, of course, has a terrible stinger and will attack anything that's coming near the colony. The moth, no stinger. But are you going to stop and see whether or not there's a stinger on the butt of that moth before you bother it? I don't think so. And it's not just you, right? It's things that eat these organisms. So a moth is a perfect food for a bird, but a bird is not going to mess with a yellow jacket. So these interactions are very, very strong. In this case, we've got one that's dangerous and one that isn't. We've got another type of mimicry where we actually look at both species having some sort of protection already. Take my moths here. They actually both taste terrible. I've been told. I've never tried one. But they both have this terrible compound that birds don't like. So why? These are two different species. So why would you bother to look like somebody else? Well, if you both look bad and both taste bad to predators, you're increasing your chances of survival by essentially training the predator faster. What do I mean by that? Well, if a bird knows that this moth at the top is yucky, and then it sees a moth that looks like this, is it going to try to eat it? No. So you've essentially increased your chances of survival by looking like somebody else. We do have some types of interactions we've talked about before that don't have to be harmful. Commensalism we usually look at as benefiting one, mutualism benefiting both. We've talked about those a lot before. So in the grand scheme of things, what we really look at is whether or not competition is occurring, whether or not predation is occurring, and all of these sorts of interactions on different levels. So you really have to look in an ecosystem at pairs of populations, right? And see, are they competing? Are they predator-prey? Are they actually helping one another? All of these types of interactions in an ecosystem are critical to the continual functioning of that ecosystem.